Jai Hind everyone, my name is Aman Gupta and I am working as an assistant professor in Ajay Garg Engineering College. My subject is software quality engineering whose subject code is BMC 035. So today we are going to discuss about introduction to measurement and inspection process. It is a very important part in software quality engineering, and documents and metrics. All these are important topics in the software quality engineering. So first of all, we have software quality metrics. So what do we understand by the word metrics? So when we talk about some numbers, and if we have some data and we can calculate, we can have some calculations on that data is simply represent the metrics, and we have to measure the software quality in terms of the metrics. Okay, it means the ability of a software product to be and to perform as per the standard defined. So what does it mean? That what is software quality? A software quality is the ability that it performs all the tasks given according to some standard due to which it has been implemented. So metric means standard, that we have different type of standards that follows ISI mark, or we can say in terms of software we have different type of standards. So my software follows that type of standard. So it ensures that the software product is of highest quality and the standard. And if my software product is developed according to some standard, and the quality has been maintained within the flow, whether my software has been developed according to that standard, then the quality of that product is of highest quality. It has the highest quality and it follows the particular standard in a very frequent or consistent manner. So software quality metrics are quantitative measures. Quantitative means we can have some calculations, or we are talking about some numbers. So they are used to assess that how good a software product or process is. So what we need to have in response, we have some product or we have some process. So we have to conclude that our software is of good quality or bad quality. And how can we judge it? We can have some calculation on that numbers. So these are the quantitative measures on which our software works. So they help organizations in which manner it can detect defects early. When we have some formulas to calculate that metrics, and the motive of that calculation is to detect the defects in a very early stage of our product or software development. Next is the monitor reliability and maintainability. So we have to monitor the reliability of the product, that how customer have been dependent on that software or the product. Can it be really easy to rely on that product or to make major decisions? Is it working or not? So it can be done according to the that metrics. Now next one is the improved development process. When we are talking about quality metrics, we can improve our development process, that as we have some standard, we have some steps to follow, that we are following that some type of SDLC or life cycle. So we have some certain steps that software has to be followed. That first of all, it has to target upon the requirement analysis, then it has to focus upon the design phase, then on the coding phase. So through using that quality metrics, the software developer can improve the development processes. Now it can control the cost and the schedule. It is also an important part that costing is a major factor to have the make the software quality control. Now, next one is the increased customer satisfaction. So, when a customer has been satisfied according to the functionality of a software or product, it is called the customer satisfaction. Now, when the process has been improved, so automatically the customer satisfaction has also been increased. Now, we have three major software quality metrics, that is customer problem matrix. We have to identify the customer problem. Next one is the customer satisfaction matrix, and the last one is the software maintenance matrix. First of all, we are going to discuss about customer problem matrix. So, what is customer problem matrix? These are some software quality measures and that capture issues reported by the users after the release. When a software has been released into the market or deployed on the server and it has been ready for the users after the release, they reflect how well the software performs in real world usage. And according to that usage, customer give their feedback that how they are satisfied with the product or the software or not. So, this is called the customer problem matrix. From the customer point of view, all the problems they encountered while using the software product, means if they are unable to, they are not going through the manual of the operating system or the device or the product or the software. So, this is also a problem for the customer. But in actual state, this is not a error. This is problem in the, this is actually a problem in the understanding of a customer. So, we can say this is the customer problem. From the all the problems they encountered while using the software product are problems within the software, including the valid defects. Maybe if some button is not working correctly, it may be the software error or the product error, but all the other things also comes under the customer problem if he or she was unable to do or to unable to perform some operation. So, the usability problem, when the user is not able to use the product or software, the documentation is not clear to them, and also the errors. These all are the problems for the customer that cannot be considered as valid defects. But they may be these errors are the valid defects, but the usability problem and the unclear documentation is not the valid defects. So, the customer problem matrix is usually expressed in terms of problems per unit month, that in a particular month how much errors or how much difficulty a user has been faced. So, there is a formula to calculate this PUM. So, PUM is equals to total problems reported by a customer for a period of time. We have taken there 1 month of time plus total number of license months of the software during the period. So, this is the formula, and here the license months means number of installed licenses of software into number of months in a calculation period, that how much month. If we have taken 1 month or 2 months, this is the install. If we have 5 license and 1 month where the customer has used this product for 1 month, then it is 5 equals to 1 equals to 5. So, 5 and how many problems he has been faced? So, suppose he faced 4 problems. So, the number is 5 equals to 9. So, PUM is equals to 9. So, PUM is usually calculated for each month after the software is released to the market, and also for monthly averages by the year. So this has been calculated to calculate the customer problems. Sorry, these metrics are especially useful for monitoring field quality, identifying the weak modules, and also to improve the maintenance process, enhancing the customer satisfaction in the upcoming fields, and reducing the future defects. So these are all the fields, or these are the points through which this matrix is really useful. Now next is, first is customer problem matrix. Now we have the customer satisfaction matrix. So these metrics measure how happy users are with a software product or service after they use it. So satisfaction matrix is to measure the customer satisfaction level, and these unlike defect focused metrics, these emphasize perceived quality, usability, reliability, support experience, and the overall value. Customer has been satisfied if functionality has been the customer who is using some product or software is working fine and in a very consistent manner, and he can totally rely on it, and the support is very good, support experience is very good, and the overall value of that product is good, then only the customer has been satisfied. So they are critical because even technically correct software can fail if customers are unhappy. Maybe the software is according to some standard, or according to some rules or set of instructions, but if the customers is not happy that its uptime is very low, so that's why customers may be unhappy at that time also. So customer satisfaction is usually measured by the customer survey data with a 5-point scale. So we can judge, or we can have that customer satisfaction by having the survey. We can ask them that tick on that point, very satisfied, satisfied, neutral, dissatisfied, very dissatisfied. So according to these points, we can have the ratio that how much customers are very satisfied or satisfied with that product, or how many customers are dissatisfied with that product or software. So based on 5 scale point data, several metrics with slight variations can be constructed and used. This can be percentage based also. So percentage of completely satisfied customers, percentage of satisfied customers, percentage of dissatisfied customers, and also percentage of non-satisfied customers. So generally a percentage of satisfied customers is used, and we can calculate the net satisfaction index, and it is also used by some companies for customer satisfaction matrix. So we can say that if the customer is completely satisfied, so he has been satisfied 100%. If satisfied, that is 75%, neutral 50%, dissatisfied 25%, and completely dissatisfied is equals to 0%. So according to that rule, that we can define that completely satisfied is equals to 100%, or we can have multiple type of scaling for that to measure the customer satisfaction. Now last one is the software maintenance matrix. So software product can be called as in maintenance phase when its development is complete. Whenever a software has been developed and deployed on the server and also is released to the market, then there will the software is in the maintenance phase when customer or the user has used that software, and during this interval, the defect arrival by time interval and customer problem is called as de facto matrix. So this de facto matrix are the defects that users has been faced according to the when they are starting to use a software when it is available in the market. So the number of defect or problems arrived mainly depend upon the development phase and not on the maintenance phase. So these are the quantitative measures used to evaluate how effectively a software system is corrected, adapted and enhanced after the deployment. So this is basically depend upon all the maintenance matrix is depend upon the they worked after the deployment of the software. So the large portion of software cost is incurred during the maintenance time. So these metrics help organizations very much because the cost is very high when they are in the maintenance phase. Control maintenance effort and cost is important to control the maintenance effort, and it can be calculated in the maintenance phase matrix, improve reliability and stability, to speed up fixes and enhancements, identify the problematic modules, and it also support the future planning of the products. So there are certain metrics that are used for the and required for the software maintenance. First one is the backlog management index. Next one is the fixed response time and the fixed quality. These are some general metrics that are required for the maintenance matrix. So first of all, that is the backlog management index. So it is the ratio between the changes received over the changes request resolved. So these are the, we can see, these are the errors that have been received in a certain number of time or a month time, and these are the requests that has been resolved in a particular time interval. So it reflects the health of the maintenance operations. So BMI is the number of change requests received over the number of change requests resolved into 100. So if we say the BMI value is greater than 100%, the backlog is decreasing. The team is actually doing their work very efficiently and they are able to decrease the backlog correctly. And if it is equals to 100%, so backlog is stable, and if it is less than 100%, it means that backlog is growing and team is falling behind. So for example, suppose in 1 month we have request received equals to 80 and change request resolved equals to 100. So the BMI equals to 125% and the team reduced the backlog significantly. So there are some advantages that it is simple and easy to compute, gives a quick snapshot of workload control, useful for capacity planning, and the highlights trend over the time. In spite of that, some advantages, we have some limitations also, that does not consider complexity of the request, that it works upon the theme that first come first serve. So it does not consider the complexity, that some request may be urgent or need to tackle first or on the priority basis. Ignore severity or the priority. Can be misleading if requests are very uneven, and it needs to be tracked continuously for the accuracy. Next is the fixed response time, and it is a software maintenance and support metric that measures how quickly a development and maintenance team responds to a reported defect or change the request. That is the fixed response time, that how early a software team can tackle the problem received, and how efficiently or how quickly they are able to handle it. So it focuses on the speed of reaction, not necessarily the full resolution time, but the response time should be very quick. That is the motive of that fix response time. It is the elapsed time between when a defect or issue is reported and the team begins corrective action. Corrective action means that he can email or he can message that your request has been received and we are tackle it, or we can trying to solve in 24 hours. That is the example. And first of all, analysis, then confinement or fix the initiation. So the usually measured in hours or days. So we for a customer care, if we have some complaint about for Airtel or for anything our and we call some customer care, then they are saying that he can or they can resolve that problem in 24 hours or 48 hours. So interpretation is, if the FRT value is low, then it means quick response and the good support received from the customer care. And if the FRT value is high, it means the slow reaction and the risk of customer dissatisfaction. For example, if a bug reported at day 1, 10 a.m. and the fix was started at day 2, 10 a.m., then FRT equals to 24 hours. So we can calculate that in numbers, and that is called the matrix. So its advantage is to simple to compute, encourages faster reactions, improves operational discipline and supports the SLA monitoring. There are some limitations also, that it doesn't measure how long the fix actually takes, can be manipulated by formally starting work early, doesn't account for issue severity or complexity, and it needs to be used with MTTR for the full picture. Now, fix quality is a software maintenance matrix that evaluates how effective a defect fix is once it has been implemented. So, it measures the correctness and completeness of the defect corrections by checking the same, whether the same defect reappears or the new defects are introduced because of the fix, or the customers report the issue again, or the same problem occurs again and again, and the solution passes regression testing or not. That means that regression testing means that if we already solve one problem, the other part or other modules of the same software should not be affected. Now, how fix quality is measured? There isn't one universal formula, but it's commonly accessed by reopen rate, that is primary indicator, and percentage of fixes that must be reopened. So, reopen rate equals to reopened defects over the total defects fixed into 100. So, lower value equals to better fix quality. Regression defect count is the number of new bugs caused by the recent fixes. If we fix some bug and it has negative effect on the other parts of some module, that is the new bugs caused by a older fix. So, fewer regression defects equals to higher fix quality. First time first rate, percentage of problems resolved without reopening is called the FTFR, that is defects fixed correctly on first attempt over the total defects fixed, and if its value is high, means it is better. Next is customer re-report rate. How often customers report the same issue after it was supposed fixed? Suppose we have the developer fixed the same issue and the customer again reopen or report the same issue. So, it means that if the value of fix quality is high, then it means stable fix is minimal regression. If its value is medium, then it has occasional reopening, and if it is low, means frequent reopenings and the side effects. So, its advantages is highlights effectiveness of maintenance work, encourages proper root cause analysis, it promotes regression testing and improves long-term stability. There are some limitations also, that it needs consistent defect tracking, can be affected by reporting practices and hard to standardize across the teams, and it also doesn't measure fix speed used with FRT and MTTR. So, that's all for today. Thank you.